Greetings, friends. Randall Nagy here. Hey, welcome out to Total Pythoneering. And as I resurrected this channel just a few days ago, I decided to test the water by reposting some of my old videos and seeing what gathered the most attention. So I posted some things on design, which I'm obviously very big on, and documentation. And you can tell by the amount of clicks that I've gotten, as well as the amount of subscribers I've gotten in less than a week, that people really are into games. And I, like you, do indeed like games. But rather than play them, I prefer to create them. To tell you the truth, it's much more fun and much more fundamental. And honestly, as a professional software developer, when we look at the challenge of taking PyTrack 9000 and boldly code where few Pythoneers code before, but in the real world, rather than starting from scratch, as we usually assume when we're creating academic demonstrations, whenever you or I arrive at our client site, 10 times out of 10, we're going to be doing something like we see here, where we're going to be updating existing code, certainly fixing and testing it. Let's begin by taking a look at the PyTrack 9000 source code as if we were a new software developer arriving on site, and let's start making some assessments before we start making our enhancements. So let's drop right into what we see here, a bunch of code that needs our understanding before it could benefit from our hacking. It occurs to me that when I get on site, what happens is I find myself dropped right into what we see here, a bunch of code that I have to fix or maintain or debug. And if we're very lucky, of course, from time to time we get to write things from scratch, but more often than not, we're stuck working at GitHub or one of their source code repositories that looks just like we see here. Of course, if we're also very lucky, whenever we're starting out on a new project, people have taken the mantra of writing things using nouns and verbs, or if you would, managing our code through object orientation, in this case, through inheritance. If you don't know much about inheritance or object orientation or even classes, go ahead and take a look at my Python training, available elsewhere right now for the moment on Udemy, and we talk about having the abstract base class or ABC module in Python 2200. For the moment, it's available over on udemy.com. Very highly rated. And if you don't know anything about object orientation or Python's abstract base class module, go ahead and take a look at Python 2200 Mastering Object Orientation over at Udemy. Now, I say I'm only going to be on Udemy for a little while longer, and part of that reason, of course, is that we're using somebody else's server, relying upon it, really. And whenever we're using somebody else's server, of course, they can cut us off for incredibly random reasons. In this case, Udemy didn't think that my icons were distinctive enough. And, for example, on a training opportunity I had going for over 7 years, they decided to ban my training simply for random reasons, which is another reason why I think we should probably get off social networking and take back our content for ourselves. So until Udemy goes out of business, of course, let's go ahead and talk about what's going on with our PyTrack business model. So you notice whenever we have a class, once we've inherited the abstract base module, specifying that we're going to be using the ABC class of the ABC module, as we have imported here, allows us to set up what we call a signature to do whatever we want all of our ships to do, in this case, by using the decorator abstract method from the ABC module. We're going to simply pass on creating an implementation that will get a glyph and return that glyph, whatever we decide it's supposed to be, to our gameplay, or if we would, our gameplay framework. Now, as a reminder, for those of you who may have forgotten, whenever we don't return anything from a function in Python, we're going to return none, or an instance of none type. And of course, by now, we should appreciate whenever we use the parentheses, of course, we're going to call the function, in this case, the function foo. And whenever we don't use parentheses, the type we're going to see is the same type we'll see whenever we use a lambda function or a class of function. Once again, if you're not comfortable with these simple concepts in Python, feel free to take a look at one of my Python 1000 or 2000 opportunities up to and including our object orientation tutorial on Udemy or other educational content providers. So because we have the Klingon ship and the Enterprise ship coming from an abstract ship, we can add other types of ships, Romulans, Packlids, even from the Q continuum if we'd like to. And whenever I have an abstract class that is not really able to be run by itself, we simply know that I'm using object orientation and abstraction, and I'm probably, in this case certainly, creating a framework. So what is a framework? Well, whenever I have an abstract class, I'm going to be having several objects based upon it. Just like I said, we can have many different ships, but we can also have many things that we're going to display, just like ship. Oh, look at this again. Here we have some interesting ideas for future enhancements. Our default console that we're using now, or our SD console, or our ST network, kind of hints that we're going to be using the default console, but it also says that I'd probably have plans to put together a network interface, and that is what we're going to do. So let's take a look at everything that has extended an abstract display. You might expect whenever we have an abstract display, we simply have to display ourselves wherever our display is, and we're going to have a message. We have the ability to show strings onto the self-display. In this case, we have a concrete function that's going to take a look at all of the strings we have in a string list and simply call display over and over and over again until we rattle it all off, whatever in our string list, onto our display. Same thing's happening here with our show banner. We use the display again. So the beauty here is that on our abstract display, whether we want to do it across the internet, on the cloud, or on TKI and TERQT, or a host of other technologies, all we'd have to do is create our own class based upon ABS display, called the initialization routine, indicating what type of display we're creating, set our width and our height for that display, and then simply overload a single display function in our own child of any ABS display device. Easy enough to do. So I suppose you see what object orientation is so wonderful. It helps us have as close to self-documenting code as anybody could possibly hope for. At this level of technology, at least. And taking a look at our console, we can see that my con class does indeed inherit from abstract display. And as you know, I'm going to have my own display function in which I'm simply going to be using Python's ever popular print message. So if we wanted a graphical or GUI-TUI version of this class, it'd be easy to do. All we'd have to do is come over and perhaps create our GUI from either Con or from ABS display. And if we're really smart, of course, and we want to use the map, then everything else would simply base our object on Con. So we could take a look at our ability to read sectors and get input from an XY position, and even create our own done domain so as to have side by side with our console program, a GUI console as well. Not a bad mission. In other words, let's go ahead and take this over to a graphical implementation. So your mission, if you decide to accept it, is to go over to GitHub, presently located under the PyTrack package on my Python 3 training organization. Get familiar with the code and see if you can do something simple. First, to clone the repository, and then simply put something different in front of your console application every time the display method is called when we're running our built-in test case as we see here. More importantly, I suppose, if you wanted to go ahead and create your own game, here again, we're using our con class, or simply run our own con. Of course, all you'd have to do is take a look at PyTrek 1.py, go all the way down to our default implementation. Notice there is no gatekeeper here for the _ name equals _ main. Whenever you run PyTrek1, therefore, no matter how you run it, we're going to run the main loop. And that's how you can start getting ready for our first and next missions for our surprisingly popular hack-a-game, Trek on Total Pythoneering. Happy hacking, and I'll see you soon.